This video is for Review Quiz 5.1, and for this first problem, they want us to solve the system by substitution. To do substitution, we need to have a variable by itself in one of the two equations, whichever one seems easiest to you, do that one. The bottom one looks to be a little bit more difficult because there's more of them. The top one, however, I think I can get y by itself quite easily, so I'm going to do that. I'm going to remove the 5x from the left-hand side. So I'm going to subtract 5x to this other side. And you'll see I get negative 6y equals 38 minus 8x. I can divide out the 6. I'm going to divide everything by the 6. It's going to be easier to work with, I think. And we get y equal to 38 over negative 6 is the same thing as negative 19 over 3. I think that's correct. And then negative divided by negative is positive. And then we get 4 over 3. And the x is on the top there. So I have what y equals, and I used this top equation for it. So I'm going to take whatever I got and plug it into the bottom equation. Make sure you don't plug it back into the original equation. It's going to end up giving you like 1 equals 1 or 15 equals 15. It's going to give you a true statement, and that's going to tell you that there are infinitely many solutions, and that's going to be potentially incorrect. So don't plug this thing back into the original equation that you used. Plug it into the other equation. The other one I used was, or the other one I have, I should say, is 9x plus 4 times y. Y is this. So I'm going to take 4 times negative 19 over 3 plus 4x over 3. And then I have this equal to x plus 3y. We already know what y is. Negative 19 over 3 plus 4x over 3. And then plus 59. Let me zoom out just a little bit here. Okay, long equation. We can solve this though because there is one variable in it, namely x. So we have to get x to one side and we're good to go. So we have 9x plus, I'm going to distribute this 4 into there. Negative 19 plus 4 is like negative 20 times 4. It's going to be negative 80 with, so negative 76 over 3 plus 4 times 4 is 16 x over 3. Distribute the 3 into there. This 3 will actually cancel with the denominators, so I don't have to worry about actually doing the distribution. We get negative 19 plus 4x plus 59. Now, what I can do is I can multiply everything by 3. That will end up getting rid of all the denominators. I'm going to do that. I want to not work with fractions if I don't have to. So I'm going to multiply everything by 3 on both sides of the equation. All right, that gives me 27x. This 3 and that 3 cancel, and that gives me negative 76. Then plus 16x. We get 3x there. Negative 19 times 3 is going to be negative 60, minus 3 is going to be negative 57, plus 12x. And 59 times 3, 60 times 3 is 180, so 177. All right, this is just a linear equation. Let's get the x's to one side. I'm going to move the 76 to the other side. I'm going to subtract the 3x. And then subtract the 12x. And on the right-hand side, we have 27x and plus 16x. 27 plus 16 is going to be 33, 43. Minus 3, so 40. Minus 12 give us 28x. Then we have 57 plus 177. I don't know. I'm just going to use a calculator to make sure I'm not doing some kind of weird work. Plus 177 plus 76 Gives me 196. Now we can divide by 28. 196 over 28 is 7. Very nice. So we know x equals 7. What does y equal? Go back up, and we know that y equals negative 19 over 3 plus 4 times x over 3. Copy that and bring it down here. Well, I just found what x is, so let's just plug that in. Negative 19 thirds plus 28 thirds. Negative 19 plus 28 is 9. 9 thirds, which is 3. So y equals 3 and x equals 7. That means the ordered pair, which says type an ordered pair in there, is x comma y, 7 comma 3. Hopefully that is correct. 3. Check. And it is. All right, next problem. It says solve the system by addition. Addition is my favorite way of doing this because I think it's faster, as long as you know what you're doing. If the problem lends itself to substitution, then it's probably going to be easier to do that, but addition is in general faster in my mind. The first thing you need to do for addition is make sure all the columns are lined up. So we have x's here, the equal signs. This needs to be y's, so I'm going to flip the bottom one around. Make it negative 7y minus 6. Now the y's are lined up and the numbers are lined up. So all my columns are fine. Now I can actually do the addition. And the most important thing to do here is get one of the variables to have the same number but opposite signs in front, the same coefficient but opposite signs. And in my mind, the easiest one to see is to make this 2x into 8x by multiplying by 4, but not just 4, because that will give us positive 8. We want to have opposite signs. So I'm going to multiply by negative 4. Distribute that into everything, and we get negative 8x equals negative 12y minus 8. I just distributed the 4 into there and then plugged it in, rewrote the equation down here. Now you see that the x's have the same sign but opposite, the same number but opposite signs in front. If we do the addition, we go straight down. 8x minus 8x is 0. Negative 7y minus 12 is negative 19y. And negative 6 minus 8 is negative 14. Okay, now we can get y by itself. Negative 19y equals 14. And finally, divide by negative 19, giving us y equal to negative 14 over 19. All right, now let's plug in this thing into one of these two equations. I'm going to use the top one. The numbers look smaller. I think it's going to be easier to work with. So y is negative 14 over 19, and then it's going to be plus 2. X is pretty much already by itself, so I just need to divide by 2 on both sides. And that gives me x equal to 3 times 14 is negative 28, 42, 19 plus 2 over 2. What I can do here is pretty much divide the numerators by 2. That's the same thing as the division by 2 there. That's the same thing as saying negative 21 over 19 plus 1. 1 is the same thing as 1 over 1, so I'm going to multiply by 19 over 19. Give me common denominators. That gives me negative 21 over 19 plus 19 over 19, which is negative 2 over 19. So I have x is negative 2 over 19. and y was negative 14 over 19. So we do actually have a solution here. Negative 2 over 19, comma, negative 14 over 19. Hopefully that is correct. Let's see here. And it is. So even with fractions, make sure you be very careful with your work. Just make sure they have common denominators if you have to add and subtract, all that stuff. A calculator can help you out a lot if you're getting stuck, but just be careful with that. It's easy to get the problem wrong. Okay, solve the system by your method of choice. In this case, I'm going to use substitution. I think it's going to be easier. It naturally lends itself, and you'll see why in a second. First off, you see that the equal signs are on opposite signs, so the addition's not quite lined up, the columns, but I have 6x solved for in the numerator, or sorry, in the top equation, and I have a 6x right here. Well, if 6x equals equals y minus 8, then this 6x also equals y minus 8. So I can immediately plug this thing right into here and get y minus 8, which is 6x, minus y equals 2. These parentheses have nothing in front of them, so they don't actually need to be written. And I get y minus y cancels, and we get negative 8 equals 2, which is a false statement. It's not a true statement, so we can immediately say the solution set is the empty set. There's no solution to this. A false statement never gives you a solution. That's correct. Okay, here we can solve by addition. 3x plus y equals 5. 15x plus 5y equals 25. I want the same sign but opposite the same number but opposite signs. So the y, I can see the y's I can easily get by multiplying the numerator. I keep saying numerator, the top equation by negative 5. What that does, negative 5 times 3 is negative 15x. Negative 5 times y is negative 5y. And negative 5 times 5 is negative 25. And when we do the addition, we get 0 plus 0 equals 0. Everything cancels. That's because these two equations are actually the same equation. They're just multiplied by, the top one's just divided by 5, or the bottom one's multiplied by 5. Whichever way you want to think about it. These are actually the same equation. In other words, they are parallel lines. And I should say that they're not just parallel lines, they're actually the same line. And if it's the same line, it crosses infinitely many times. Therefore, it has infinitely many solutions. If you get a true statement like we have here, 0 equals 0, that means there's infinitely many solutions. Okay, last problem. You invest in a new play. The cost includes a $28,750 overhead. So it's a kind of like a one-time fee, or like a renting fee that you have for whatever, if you're doing it for a month or something like that. There's also a production cost of $2,500 per performance. So like for actors and maybe like materials you use up during a performance, whatever that might be. A sold out performance brings in $31.25, so that's kind of the income, the revenue as it's called, in for the play. It's asking us to write a cost function and a revenue function. So the cost function is how much do you spend for a play, for a performance, and that comes in with the overhead, $28,750, plus, this is a one-time fee, plus the per performance fee. So if you have, it says here, let X represent the number of sold out performances. So if we do X performances, say like in a month or whatever, that means we're going to have $2,500 times X, because each performance is $2,500. If you do 3, then it's going to be 2,500 times 3. And you have to always add on this flat overhead fee as a part of your cost. So this is actually our cost function here. C of X as it's called. 28,750 plus 2,500 X. It's a flat fee and then the incremental fee per performance. The revenue function is how much do you bring in for performance, and we know that we are having X be sold out performances. X is the number of sold out performances, and it says a sold out performance brings in 3125. So if you sell out 10 performances, you're going to bring in revenue of 3125 times 10. If you sell out X performances, you're going to bring in 3125 times X. So that's the revenue function, 3125X. All right, these questions are kind of dumb because they're kind of flipped. The break-even point is when the costs and the revenue are the same. That's where revenue and overhead costs. No, it's not just overhead costs. It's total cost. The revenue where the cost and revenue are equal, it's going to be D. That's what the break-even point means. To find that, all we have to do is set C of X equal to R of X. Literally what we have here, we can think of C of X and R of X as just a Y variable. And we have a system of two equations. We already have this thing solved for Y, so substitution is about the easiest thing we can do here. Set them equal to each other. We have the top one, 28,750. Make some room. 2,500X equals 3125X. Now I can, I have one variable, I have one equation, I can solve this for X to get my solution. I'm going to subtract 2,500X from the left-hand side. Gives me 28,750 equals, this should just be 625, I think. Get X by itself. See what that is as equal to 2750, 28,750 over 625. It gives us 46. So if we check our work, 28,750 plus, let's see, 2,500X. X is 46. This gives us 28,750 plus 2,500 times 46. A total of $143,750 as a cost for 46 plays. And if we sell out 46 plays, 3125 times 46. Yes, we get the exact same number, which is what you should get. 143,750. So let's check. The number of sold performances that we want is 46. Check the answer. That's all correct. What this means is that if you do not do at least 46 sold out performances, you will lose money in this play. If you want to gain money, you have to do more than 46 performances. If you only do 46 sold out performances, you will actually not gain any money. I mean, all the money that you make is going to the costs of the play.